Today we will learn about dissolving. Our question of the day is, where does salt go when you dissolve it in water? First, let's consider molecules that have partial charges. They can attract the full charges on ions. This is called the molecule-ion effect. Remember how water is a polar molecule? That means it has partial charges because the molecule is asymmetrical. When water is brought near ions, water will use its partial charges to break apart the crystal lattice. This process is called dissolving. It is the reason why water is known as the universal solvent. Before we move on, let's review some vocabulary. The solute is the substance being dissolved. Usually, this is something ionic. The solvent is a substance doing the dissolving. Usually, this is water. When you are dissolving something, the negative end of water, the oxygen, is attracted to the positive ion, and it pulls it away from the negative ion. The reverse is true as well. The positive hydrogen is attracted to the negative ion and pulls it away from the positive ion. This is called dissociation. This results in an aqueous solution where the ions are mobile. We call what is created an electrolyte. In this problem, aqueous sodium chloride, which is sodium chloride in water, dissolves and dissociates into its ionic parts, sodium +1 and chlorine -1. An electrolyte is a solution that conducts electricity. These substances have other compounds dissolved in them, so an electrolyte has a lot of positive and negative ions dissolved in water. Now let's think about covalent bonds. Acids, although covalent, will dissolve in water. Nonpolar covalent substances do not have the same type of response when mixed in water. This is because they don't have charges, partial or full, to be pulled apart by water. This is why oil does not dissolve in water. The mixture of oil and water will not mix because they have different polarities. We use the phrase like dissolves like to remember this. This means that substances with similar polarities will dissolve in each other. So polar substances dissolve in water and nonpolar substances dissolve in oil. Now pause the video and try the show what you know questions. When you are done, you may resume the video and check your answers.
So, what is the difference between solutes and solvents? The solute is a substance that is dissolved, and the solvent is the substance that does the dissolving, usually water. So, the solvent is the thing that you have more of, and the solute is the thing that you have less of. Why are aqueous ionic compounds considered electrolytes? Well, electrolytes occur when ions are mobile, they can move, and ionic compounds dissolved in water are all broken up into their ions, which are separate and can move around. Now, let's consider each of the following examples and whether they will significantly dissolve in H2O or not. First of all, CH4, methane, will not because it is nonpolar. Another reason it will not dissolve is because it is a gas, which makes it hard for it to dissolve, but you can get it to dissolve under certain conditions, such as high pressure. Next, B is KCl, potassium chloride. Well, this is ionic, so yes, it does dissolve in water. HCl, similarly, will dissolve in water because it is a polar covalent and an acid. Magnesium sulfate is an ionic compound, so it does dissolve in water, and so does NaHCO3. F is sodium hydroxide, NaOH, which is ionic, so yes, it will dissolve in water, and then HC2H3O2 is an ionic acid, therefore it will dissolve in water as well. So in conclusion, ionic and polar covalent compounds will dissolve in water, while nonpolar compounds will not. Being in a gaseous form and not a solid is another reason for something to not dissolve in water very well. Now let's consider number 4. In an aqueous solution of acetic acid, What is the solute and what is the solvent? Since it is aqueous solution, the solvent must be water. Therefore, the other compound, the acetic acid, is the solute. Next, we will draw a picture of what Na2S will look like when dissolved in water. Note that you will need twice as many sulfur ions as sodium ions. If the purple is sodium and the green is sulfur, then you notice we have 1, 2, 3, 4 Na2S's here. Notice how they are not bonded together, they're just floating freely. That's because the water's positive hydrogens will be attracted to the negative sulfur and its negatively charged oxygen will be attracted to the sodium. That means that the negative sulfide and the positive sodium ions are both surrounded by water and therefore they can move freely.